Hello everyone, welcome to uLearn Education Online channel. In the previous video, we have seen in detail about the transmission of FM signal using the reactance modulator or a direct FM transmitter. And also we have seen what are the blocks involved in the transmission of FM signal using reactance modulator. But using of reactance modulator and oscillator in the circuit, it has some drawbacks. That is, by using the oscillator in order to generate a carrier signal, we cannot transmit a stable signal, that is a stable FM signal at the transmitting antenna due to the variations in environmental conditions such as temperature, humidity, supply voltage, and also the aging of active components, which will cause the frequency deviation that is present in the FM transmitter. And also, by using an oscillator, we cannot generate the higher carrier frequency signal. Okay, it means that we will generate a higher frequency carrier signal, but it will not be stable. It means it simply occur like a damped oscillations. That's it. Its amplitude will not constant. Okay, so that's why we should not use the reactance modulator FM transmitter for high frequency FM signal to transmit. And also, if you see in the previous video, the reactance modulator circuit will control the tank circuit. That is, the modulating signal directly controls the tank circuit of an oscillator. So, in order to overcome these drawbacks, we have to generate a high frequency stable signal. In other words, we can say that we have to use the frequency stability circuits. Okay, and how we can achieve this frequency stability circuits is by simply using the frequency stable circuit in the feedback path of reactance modulator FM transmitter. So here, one frequency stability circuit we are using is an automatic frequency control circuit, that is an AFC circuit in the feedback path of reactance modulator or direct FM transmitter. Now let us see how the circuit will be. Okay, so if you consider this upper part, it is simply the reactance modulator FM transmitter block diagram. So in order to obtain the frequency stability in the direct FM transmitter, we have to make use of an automatic frequency control circuit. Okay, this automatic frequency control circuit will consist of mainly 4 blocks. One is the crystal oscillator, which will generate a carrier signal frequency, and second one is the mixer. So to this mixer, if you observe, one input to the mixer is a crystal oscillator input, and second input is the sample of an FM signal that is generated during the process of modulation. So here the output of a mixer is, we know that the mixer will produce some signal and different signal, but here we have to consider the difference signal of crystal oscillator and a sampled signal, that is an FM signal frequency. Here this crystal oscillator, the other name we can call it as a fixed oscillator. It means that its frequency is fixed. Thereafter, the difference frequency of mixer is applied to the frequency discriminator circuit. Now what the frequency discriminator circuit will do? It simply generates an error voltage that is corresponding to the difference frequency of output of a mixer. Okay, so here the output of a frequency discriminator circuit is an error voltage. If this error voltage is 0, then we can say that there is no shift in the frequency of a carrier signal that is used for transmission of FM signal. For example, if there is an error voltage, that is if there is a correction voltage, then it is passed through a low pass filter. Now what the low pass filter will do? It simply remove the unwanted frequency, that is a modulated signal frequencies, and allows the variations in the error voltage, which is proportional to the difference between the sample of the output waveform and the fixed oscillator. Okay, now this error voltage is directly applied to the reactance modulator. Now here we can call this an error voltage as a correction voltage. Now this correction voltage is being applied to reactance modulator. Now this correction voltage changes the frequency shift of the reactance modulator in a direction that will automatically restore the correct transmitter frequency. Okay, so if this error voltage is 0, then there is no change in the transmitter frequency of a carrier signal will be present, and if this error voltage is non-zero, then with this error voltage this reactance modulator has to shift its frequency level, that is a correct transmitter frequency. So in this way we can achieve the frequency stability in FM transmitter by using a feedback circuit, that is an automatic frequency control circuit. So finally, in brief I can talk, with the use of feedback path, that is an AFC circuit, we can easily achieve the frequency stability in the FM signal if we consider that the carrier frequency should be of higher order. Okay, and also there is no frequency deviations that is present in the carrier signal frequency if there is a change in environmental parameters such as temperature, humidity, aging of components that are used in the circuits, and so on. Okay, so with the help of an AFC circuit we can easily achieve the stability of frequency in the FM transmitter. That's all about the concept of frequency stability in direct FM transmitter or a reactance modulator FM transmitter. Thank you so much for watching our videos. Please subscribe to our channel. Keep supporting. Thank you.